video, we are going to explain about a project titled Active Learning from Imbalanced Data, a solution of online weighted extreme learning machine. Now coming to the introduction part, in the context of imbalanced data, OWELM assigns higher weights to minority class samples, effectively emphasizing their importance during the learning process. This strategic weighted of instances ensures that the model gives equal consideration to both majority and minority classes, resulting in improved classification performance on imbalanced datasets. By combining the strengths of active learning and OWELM, this approach offers a promising solution for addressing the class imbalance problem in real-world scenarios. It empowers machine learning models to make more informed decisions, achieve better generalization, and deliver more equitable classification results, even in the presence of highly imbalanced data distributions. As a result, active learning from imbalanced data with online weighted extreme learning machine holds the potential to advance various applications such as fraud detection, medical diagnosis, and anomaly detection, where imbalanced data sets are prevalent and accurate classification is paramount. So our main objective of active learning from imbalanced data with online weighted extreme learning machine is to create a more accurate and unbiased classification model for imbalanced data sets. By strategically selecting informative samples through active learning and emphasizing the significance of the minority class with OWELM, this approach can significantly improve the model's ability to generalize and make equitable predictions across all classes. As a result, the method holds great promise for enhancing the performance of various machine learning applications where imbalanced data is prevalent and precise classification of the minority class is of utmost importance. By iteratively selecting and adding new instances to the training set, the model can focus on learning from the minority class, which is often challenging to classify accurately due to its limited representation. Active learning ensures that the model allocates more attention to these critical samples, leading to improved classification performance on the minority class. Coming to the requirements part, there are two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first upload dataset. The process begins with uploading the dataset to the system. The dataset contains the necessary information required for a specific machine learning task. It typically includes features, that is input variables, and corresponding labels, that is output variables, that are used to train and test the algorithms. Second, compute SVM ACS label. After the dataset is loaded, the system computes the SVM ACS, that is support vector machine with active learning by committee sampling label. SVM ACS is a method that combines support vector machine with active learning techniques to improve model performance. It uses a committee of SVM models and actively selects information samples from the dataset for labeling. These labeled samples are then used to train the SVM model, iteratively improving its accuracy by iteratively selecting the most informative samples for labeling. Third, compute AOWELM label. Next, the system computes the AOWELM, which stands for Online Weighted Extreme Learning Machine label. It is an extension of the extreme learning machine designed to handle online learning scenarios where data arrives sequentially. It assigns higher weights to samples from the minority class, addressing the issue of class imbalance in the dataset. The computation involves using this specialized algorithm to learn from the dataset and generate class predictions. Fourth, extension of AOWELM with feature extract selection. To further enhance the AOWELM model's performance, the system extends it with feature selection techniques. Feature selection involves identifying and selecting the most relevant and informative features from the dataset. By reducing the dimensionality of the dataset, the model can focus on the most critical aspects of the data, improving efficiency and reducing overfitting. Fifth, view computed label. Once the SVM ACS and AOWELM labels are computed, and the AOW ELM is extended with feature selection, users can view the results. The computed labels represented the predicted classes for each sample in the dataset based on the respective algorithms. Viewing the computed labels allowing users to assess the performance of the models, understand how well they are classifying the data, and identify any potential issues or improvements. 6. Accuracy graph. To provide a comprehensive analysis of the model's performance, an accuracy graph is generated. This graph illustrates the accuracy of the SVM ACS and AOW ELM models over multiple iterations or as the data size increases. The graph helps visualize how the models improve with active learning and feature selection, and allows users to improve and compare their performance side by side. Now, coming to the execution part, to execute the project, first we need to open the code folder. Here we have a folder named as dataset. In this we are containing some text files. Here, this is the Python file which is containing the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. This is the graphical user interface. With this we are interacting with the program. Now click on upload dataset button to upload either seed or yeast dataset. Here I am selecting seed dataset, and after uploading it will get this. Now click on compute SVM ACS label button to calculate weight of each label in imbalanced dataset, and then calculate SVM ACS accuracy. So here on this screen we can see that 72% accuracy, and we can see total dataset size is 210, which are containing 7 columns, and in that application using 168 records for training SVM model and using 42 for testing purpose. And to calculate accuracy by predicting or computing class labels of those 42 records, we have to click on compute AOW ELM label button to compute label of 42 test records using online active learning technique with ELM classifier. So here on this screen we can see AOW ELM able to get 80% accuracy to compute labels for test records. Now click on extension AOW ELM with feature selection. So here you can see that there is 90% accuracy for AOW and ELM technique with PCA feature selection algorithm. Now click on view computed label button to view labels of all 42 test records. So here on this screen, for each test record we got class labels as 13, 113, etc. Now click on accuracy graph button to get the accuracy comparison between all 3 algorithms. Here in this graph we can see x-axis represents algorithm names and y-axis represents the accuracy of each algorithm. So from this graph, AOW ELM with PC extension work got better accuracy. Now coming back to the conclusion part. In conclusion, active learning from imbalanced data, a solution of online weighted extreme learning machines, presents a promising approach to addresses the challenges posed by imbalanced datasets in the context of online learning. The proposed method combines the benefits of active learning, which focuses on selecting information samples for labeling, with the effectiveness of weighted extreme learning machine, which can handle imbalanced data. Additionally, the integration of online weighted extreme learning machine, that is OWELM, further strengthens the algorithm's performance. OWELM efficiently handles large-scale datasets and assigns higher weights to the minority class samples. This strategic weighted ensures that the model devotes equal attention to both majority and minority classes during the learning process, overcoming the bias that can result from imbalanced data.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.